I can insert the test module, and I will insert, for example, the QuickCMC to do the wiring check, because this is the first step of your testing and commissioning job, is to do the wiring check before you start checking the protection function. So I can rename this one to be wiring check, for example, and I will enter. Now this is the first module we will talk about, which is the QuickCMC. As you can see here, we have 3 channels of voltage and 3 channels of current. But I can declare the other 3 analog outputs from the current, as you can see here. So I can make it like, so it's IL1 is used already, so I can use it I1-1, I2-2, I1-3, and here it will be I1-2. So now I will have 6 channels of current. As you can see here, you cannot make any change because you already specify the number of channels of current and voltage in the global hardware configuration. So this one is a local hardware configuration, as you can see. So just you have the only thing you can do here, you can make it used or not used based on your application. But the number of channels and number of voltage and the current channel will be declared and it will be identified by the global hardware configuration. For example, here I have a lot of binary inputs, so I can make from 3 up to 10. I can make it not used because I will use only 2 contacts. Contact 1 is the trip, contact 2 is the start. So you are allowed to specify this one used or not used in the local hardware configuration, but some setting you have to adjust it in the global hardware configuration if you need to do any change. So for example, here I have entered the VT ratio and the CT ratio inside the device REU file. So I can double click here, right click, and I will specify this is the nominal value. It will get the nominal value from the voltage line to neutral from our device setting. And I can make it equal magnitudes to all 3 phases. It will be the same value. If you need to change, you can change manually. You can inject different values of voltage and current just to make sure this is red phase, this is yellow, this is blue phase. And also you can identify by the angle, because the angle here is 0, here minus 120, here is 120. So in case of you do a wiring check and measurement, you can specify which channel of voltage, which channel of current, and for R and Y and B. And also I have specified the CT ratio 600/1. So if I click right click and click the nominal value, it will detect automatically 1 ampere from the device setting. I can do the same and make equal magnitude, and here also I can adjust it as a nominal value and the equal magnitude, or you can specify your values manually to make a segregation between the red and yellow and the blue. So I can inject the phase R 500 milliamp, phase Y 750, phase blue is 1 amp. Okay, is that clear? Okay, I will explain this home ribbon and view ribbon because it will be very beneficial for all other modules because it's almost the same. I will explain one by one. So here is the test object, as you can see. So you can reach to local test object from each module. Okay, so this is a local test object. If I change any kind of values here, it will be reflected to the global test object because, as we explained in our presentation, it's bidirectional effect. If I change in the local, it will change the global test object, but not like the hardware configuration. The hardware configuration, the global one affects the local hardware configuration, but the local cannot affect the global hardware configuration. So it's only one direction. Okay. This is the first one. We have also the hardware configuration. So here is the local hardware configuration. You can use or you can configure use or not use in your local hardware configuration. And we have also here switch off on trigger. As you can see here, it's switched off on trigger. So if you select this binary input 1 and you take this value, it will be switched off if the binary input 1 closed. So it will switch off the injection. Okay. If you untick this one, it will not switch off on trigger. Other option here, it will be switch off on time. You can make switch off after 5 seconds, 10 seconds, just to be enough for you to take the measurement values from the software or from the local HMI of the protection relay. So you have different options here in the switch off. Also, you can stop the ramp at 0. And this one is very good because the CMC will switch off at the nearest 0 crossing of the sinusoidal wave of the current waveform. Okay, so if the trip happens inside the sinusoidal wave, it will wait until the next 0 crossing and then it will switch off the current injection. Okay, so it is just, this is for your safety and for the protection relay safety. We have another options also, which is synchronized to input, can be synchronized to input to start injecting. So you can synchronize to binary input number 10. If I have a carrier receive, I can inject this values to the QuickCMC. And this one also is the auto report. So if you select this one, it will automatically create a test report after the injection of current and voltage values. Okay. Now I will make it switch off on trigger, and I will specify this binary input one, which is the trip contact, to be the trigger option for our QuickCMC. And it will give me the trip time here after it getting triggered by the binary input status. Then we have the prefault, which can make a prefault. For some protection relays need a prefault to sense the tripping fault. So you can simulate 10% from the load, which means 10% from 1 ampere, it will be 100 milliampere, and it can be also simulated as a 50 or 100% from the load, or you can make it 0 and not injecting any prefault in case of you don't need to inject a prefault. And here is the start and the stop button of the QuickCMC. And then we have the hold values, as you can see here. And this button is very beneficial in case of you need to change the values of the current and the voltage, but no need to immediately inject this value. So if I press the hold button, as you can see, I can change here to be 600, for example, but it will not change immediately. And here I can change it to 800. So now this values is holded. So it means not injected to your protection relay. Once you remove this hold button, it will be automatically injected to your protection relay. And this is beneficial if you need to change the 3-phase. And after that, you can release the hold button to apply the changes of the current values. Okay. Then we have also add to report, as you can see. If you are activating the auto report, no need to press add to report. But if you are not activating this auto report and you can start, as you can see, here is a simulation because I am now in the offline mode. So this is the trip time, which is 684 milliseconds. And now I can press add to report. As I said in the presentation, this is general test module, which means it is need a manual assessment for the results or the measurement values. So I can press here, I can rename the title of this report. I can make a measurement check. And I can set here the values, okay, or I can specify the IL1 is equal to IL2, IL3 to be printed out inside my test report. Then I will click bust. So this is a completely manual assessment, okay, because this is a general test module. Then we have also to add a comment, if you need to add a comment here in your test report. And here is the report setting. We have different options in the report setting. You can choose the short form, and we can choose the long form of the test report, or I can define and customize what I need to be printed in my test report. So if you press define the report, you can select the test result to be printed. For example, if I need binary outputs, if I need analog inputs to be printed, I need the comment to be printed in the test report, and many more. Or if you need all values, as you can see, and then you can press OK. Then here in the view ribbon, you have a lot of options in this view ribbon. We will start from the left. Here is the manage views, which now we identify and activate the lock views. So you cannot change this lock for now. But if I press unlock views, as you can see, now it's unlocked. So I can change. Then if you need to discard this one, you can press the apply layout as a default, and it will give you the default value again, which is the default view. Then we have the test view, which is this screen. And we have also the phasor view, as you can see here, the phasor of IL1, IL2, IL3, and the voltage as well in the phasor view. And also the impedance view, in case of you injecting an impedance from the set mode here, we have some options. We can inject direct voltage and current values. We can inject line to line. We can inject symmetrical components such as positive sequence, negative sequence, zero sequence. We can also inject some impedance based on the current constant or voltage constant or the source impedance constant, and also can be percentage, which means relative to the setting. So if I choose this impedance, I can specify the fault type from here, which is line to ground, line to line, or 3 line, and you can specify this range of the line length. So I can make it 80% from the line length, and I can specify the current. As you can see here is the I test, because I choose the current constant mode, so it can be shown here in the impedance plane if you are specifying the impedance plane of the protection relay. Then we have some we will get back to this direct. We have also the status history, which appear in the bottom corner here to give you indication about the connection of your CMC, and if you have overload monitor, as you can see here, it will indicate by the yellow phase. So if I open the IL1 for the CT, it will be yellow LED here, and I have to reconnect the IL1, and then I press this IL1 button here to be green again, which means the overload is gone and no any other errors. We have also some values here in the view robot to be secondary or cycle for the time, so I can specify this one to be cycle. As you can see here now, the delay you have to identify by cycle time, or you can identify by the second time. Also the primary and secondary values, as you can see here now, you can get the primary and the secondary values. So here is the kilovolt and kiloamp. If you specify as a secondary, it will give you the secondary values based on the CT ratio which you configure in the device review file. Okay, we have also some absolute and relative. For some relays, it's used the relative module, which means it's a per unit for the nominal value of the current. As you can see here now, it's 2 IN, and IN equal 1, which means 2 ampere. So if you need absolute value, you can return back to the absolute value. It will give you the ampere and the voltage values. And here is the always on top, which allows you to fix the QuickCMC view in always on top. If you have any backside or running softwares, it will be fixed and maintained in the top, as you can see from here. So now we will talk about the other settings here, as you can see, because we can do the ramp and the pulse ramp using the QuickCMC as well. So for example, I need to use QuickCMC for ramping up and ramping down the current to get the pickup and the drop-off value of the overcurrent protection, for example. So I can select here IL1 or IL2 or IL3 or line to line or 3 line together. Then I can specify here the nominal value, and I can make equal magnitudes. For example, if I have overcurrent function at 1.2 ampere, so I will start from 1 ampere, and then I will specify the signal which I need to ramp up or ramp down to 3-phase current. And here you can specify the quantity to be magnitude or the phase angle. So I will specify it as a magnitude. Then I will get the step size here, which means the increment step size or the decrement step size to check the pickup and the drop off. So I can make it 0.1, which means 100 milliamp. So if I start injecting now, as you can see now, IL1 is 2 ampere, IL2 is 2 ampere, IL3 is 2 ampere. I will make it the nominal values to start. And now I don't need to check this one. So I will start. As you can see here, we have 1 ampere. Once I press this button, it will increase to 1.1 and also 1.2, 1.3 with each press. Or you can identify to be auto step. And each step you have to identify the time, and it should be greater than the expected pickup time, which is in normal cases it will be instantaneous. So I can specify this time to be 0.1 second. Then I will press only up arrow. As you can see, it will be automatic ramping up or ramping down if I press the down arrow. So you can use this button and this screen to make ramping up or ramping down for the current and the voltage, and also you can use it as a pulse ramp, but in that case you have to identify and configure the reset case, and you can identify which one is the start contact of the overcurrent to detect the pickup value of the current in that case. Okay, here is the binary output signals. If I need to identify any binary output to simulate any event for the rotation relay binary input, I can use any binary output from the CMC to be connected to the relay binary input. And here is the report view, as you can see. So the report view, you can see it from here. This one, it will be manually assessed. So you have to click passed or failed manually to check the measurement or the wiring check values for the voltage and the current. And it will be assigned here. In case if you need to add any result or any tables to your report setting, you have to select the short or the long form, or you can define which field you need to add. So for example, I will add the comment. So it will add the comment here. If you have any comment, you can add the measurement values is okay, or you can add the values from the HMI of the relay. IL1 equal 600, IL2 equal 500.